Let's take a look at using the limit definition of derivative to find the derivative of sine of x. Now, as we go through this process, there are some things that we will need to use while we apply the limit definition. First of all, we need the sign identity for sine of a plus b, and that is sine of a cosine of b plus sine of b cosine of a. We will also need this limit as delta x goes to 0 of cosine delta x minus 1 over delta x equals 0. Now, don't let the fact that we have a delta x as our variable in this particular limit. I could just as well have called that x goes to 0 as cosine of x minus 1 over cosine of x. The behavior of that ratio of cosine variable minus 1 over that variable does not depend on the name of the variable. So in the way it's going to appear in our definition, the variable will be delta x. However, it could just as well have been the variable x. Now, just to convince you of the validity of that limit, we have here on the right the graph of cosine of x minus 1 over x. And we can see that as x gets closer and closer to 0, that this function gets closer and closer to 0. So you should be fairly well convinced that the limit as of cosine of delta x minus 1 over delta x equals 0. And we can see that here from this graph. From both sides of x equals 0, the function is equaling, the limit of the function is equaling 0. Now we will also need the limit as delta x goes to 0 of sine of delta x over delta x equals 1. And as before, here on the right, we have a graph of the function sine of x over x. And we can see that as x approaches 0, our function or our y values are in fact approaching 1. So you should be fairly well convinced of this limit. And lastly, we will need the limit definition of derivative. So let's go ahead and see how this works. So we start out by applying the limit definition. So we'll have f prime of x equals the limit as delta x approaches 0 of sine of x plus delta x minus sine of x all over delta x. At this point, we need to be able to apply the sine property. Okay, we've got the sine of a sum inside or in our numerator, and so we need to expand that. So that's what we'll do next, is apply that property. So we will have the limit as delta x goes to 0 of sine of x cosine of delta x. So in this property, a is x and b is delta x. So sine of x cosine of delta x plus sine of delta x times cosine of x all over delta x. Oops. And then I forgot my minus sine x in my numerator. Okay. So now we try and simplify up the numerator a little bit. And we note that there are two terms that have a sine of x in them. So we will group those together and factor. And as I factor, I'm going to remember that this last term, this minus sine of x, is really sine of x minus, times 1 when I factor that. So here we go. So equals the limit as delta x goes to 0 of sine of x times cosine of x, cosine of delta x, that's this term, minus 1, that's this term, plus sine of delta x, cosine of x, all over delta x. Now, in essence, I have two terms in my numerator, this sine of x times the quantity cosine of delta x minus 1, plus my second term, sine of delta x times cosine of x, over a common denominator. So I'm going to separate those, and it will look like this. The limit as delta x goes to 0, we'll have sine of x times cosine of delta x minus 1 all over delta x, plus the limit as delta x goes to 0 of cosine of x times sine of delta x all over delta x. Now, delta x is the only quantity headed towards 0. So I can bring this sine of x in front of my limit operator. Same is true here in my second limit. The delta x is the only variable being affected by the limit. So this cosine of x is not affected by the limit. So I can pass it through my limit operator as well. So then we end up with sine of x times the limit as delta x goes to 0 of cosine of delta x minus 1 over delta x plus cosine of x times the limit as delta x goes to 0 of sine of delta x over delta x. Now is when we can apply these special limits that we have over here on the left. So this cosine limit as delta x goes to 0 of cosine delta x minus 1 over delta x, that is equal to 0. So this goes to 0. And the limit as delta x goes to 0 of sine of delta x over x, we know that that goes to 1. So this goes to 1. So we end up with sine of x times 0 plus cosine of x times 1, which equals cosine of x. So for f of x equal to sine of x, f prime of x is equal to cosine of x. So now let's take a look at finding the derivative for the cosine function. Again, we'll be using the limit definition of derivative along with the special limits as delta x goes to 0 and the cosine identity, that cosine of a plus b is equal to cosine of a times cosine of b minus sine of a times sine of b. So let's go ahead and see how this goes. So f prime of x is equal to the limit as delta x goes to 0. Our function this time is cosine of x. So cosine of x plus delta x minus cosine of x all over delta x. Now, we want to go ahead and expand this cosine of x plus delta x. So we will be using this trig identity. And keep in mind that x plus delta x is what is inside, or is the argument of our cosine function. So a will be x and b will be delta x. So continuing on, we have the limit as delta x goes to 0 of cosine of x times cosine of delta x minus sine of x times sine of delta x, all over delta x. And I forgot this minus cosine of x at the end of our numerator there. So don't forget that minus cosine of x. Okay, all right. So as I look at this, I notice that I do have a common factor of cosine of x here in my first term and in my last term. And let's remember that when I go to factor out this cosine of x, it's actually cosine of x times 1. So when I factor that out, the cosine of x out, there will be a 1 remaining. So let's go ahead and factor those out. So we have the limit as delta x goes to 0 of cosine of x. Factoring that out, I'm left with cosine of delta x. That's this first term. And now this last term, minus 1. And then minus sine of x times sine of delta x. This whole thing over delta x. Now, as I look at my numerator, I basically have two terms in my numerator. I have this cosine of x times the quantity cosine delta x minus 1, then minus, and then the quantity sine of x times sine of delta x. So we're going to go ahead and separate those in our limit, and so we'll end up with the limit as delta x goes to 0 of cosine of x times cosine of delta x minus 1 all over delta x minus the limit as delta x goes to 0 of sine of x times sine of delta x all over delta x. Now, in this limiting process, delta x going to 0 will not affect cosine of x. So I can pass cosine of x through my limit. Same is true over here for my second term as delta x goes to 0. Delta x behavior does not affect the sine of x function, so we can pass that through the limit. So we end up with cosine of x times the limit as delta x goes to 0 of cosine of delta x minus 1 over delta x minus sine of x times the limit as delta x goes to 0 of sine of delta x over delta x. Now this is the point at which our special limits become important for us. We know that the limit as delta x goes to 0 of cosine of delta x minus 1 over delta x is 0. So this part goes to 0. We also know that the limit as delta x goes to 0 of sine of delta x over delta x goes to 1. So this limit goes to 1. So we end up with cosine of x times 0 minus sine of x times 1, which is equal to negative sine of x. So for f of x equal to cosine of x, f prime of x is equal to negative sine of x. I hope this is helpful.